part of the lesson is on adding vectors in different directions. So this is the day 1, day 2 triangles that I was referring to earlier. So what we're going to do is follow some different steps. So I'm going to insert a new page here real quick. And these are the steps that I'd like you to take when it comes to these finding resultants of like multi-step problems. Once again, for instance, instead of traveling this way and then that way, you could have just gone this way. So solve for that resultant's magnitude and direction. All right, so on this slide, these are the steps that I want you to take and able to do that. Step number 1 is to find x1 and y1, and that's very loose, guys, okay? That could be like the first displacement, the second displacement of the day 1 triangle, like in your x and y components, or it could be the velocity of the x component and the velocity of the y component for day 1, but we're just arbitrarily going to say x1 and y1 right now. So find your x1 and y1 components from day 1 triangle. The second thing that you want to do is then find x2 and y2 from the day 2 triangle then. Once you get those out, then you want to get your x total by using x1 plus x2, and you also want to get your y total by adding up y1 plus y2. The fourth one comes into play with now having to draw your new triangle, since now you have the x total and the y total. So what you want to do for this draw new triangle is figure out which quadrant you want to start with, your x or your y. And the way that you will know which one you want to start with is look at day 1's triangle. Okay, so first vector drawn on new triangle is first vector drawn on day 1's triangle. So looking back up at day 1, let's say you went north of east, so you went east first, so you want to draw your x component first. Or if it would have said east of north, then you'd want to draw your north component first, because that's the one that you had to draw first. So draw your new triangle, and then number 5 is use Pythagorean theorem to figure out the magnitude, and use inverse tan to figure out the direction. So many degrees north of east, south of west, etc., etc. So these are the steps that I want you to take. So for this girl, she starts off by walking 27.0 kilometers on day 1. So I'm going to call that XR of 1 is 27.0 kilometers. And she does that at a theta of negative 35 degrees because she's moving south of east, so that's negative 35 degrees. And then on the second day, she moves a total of 41.0 kilometers. And she does this at an angle of 65 degrees north of east, so that would be a positive 65 degrees. So you want to find the XR and the theta R for this problem. Since you're talking about kilometers, that will be your units here, and then degrees, I don't know of, I don't know. All right, so the first thing we want to do is draw our day 1 data. So for day 1, we went south of east. So you want to go east and then south. Here's your theta, here's your resultant. So you want to solve for x1 and you want to solve for y1. I like to put those positives and negatives in there because it'll show you, when I get the final answer, should it be a positive x, should it be a negative y, etc., etc. So on this, now look at your relationship to theta. Your relationship to theta is adjacent, so thinking back to SOHCAHTOA, your arrangement would be adjacent over hypotenuse. So x1 equals cosine theta times x1r, whereas y1 is going to be sine theta, because sine is opposite of theta, times x1r. All right, let's jump back up here. This would be the cosine of negative 35 times 27.0. And this one would be the sine of negative 35 times 27.0. In your calculators here, you should see about, and I'm just going to skip to the chase, 22 kilometers. And for your y1, you should have negative 15 kilometers, which makes sense because your x1 should have been positive and your y1 should have been negative. Okay, let's look at your day 2 triangle. Your day 2 triangle says that you went north of east. So go east and then go north because you went north of your eastern line. Throw in theta, throw in your resultant, and let's solve for x2 and y2, knowing that they both should be positive for this one. So once again, this is a bow tie triangle because x is cosine and y is sine. So x2 is cosine theta times x2r. You understand how to plug in the math now at this point, so let's just skip to the chase. That should be a 17 kilometers for x2. And your y2 is sine theta times x2r. Therefore, your y2 value should come out to be 37 kilometers. All right, so now what we want to do is we want to get our x total and our y total. So x total is x1 plus x2, in which x1 was 22 kilometers and x2 was 17 kilometers, thus giving us an x total of 39 kilometers. Our y total would be y1 plus y2, whereas y1 was a negative 15 kilometers and your y2 was a positive 37. Therefore, our y total was 22 kilometers. Step number 4 now is draw that new triangle by looking at day 1's triangle. You first moved in the x direction, so you want your x total to be drawn first. And that is a positive 39, and then you have a positive 22. So this is what the new triangle should look like. Make sense? Check that out. Okay, so number 5, now we want to use the Pythagorean theorem to figure out what our magnitude would be for our ultimate answer. So that would be the square root of 39 squared plus 22 squared. Plugging that into our calculator, we should be seeing 45 kilometers for XR. All right, ask yourself, on this triangle, did I draw a bow tie or an hourglass? Well, you drew a bow tie because you're going opposite over adjacent. So that would be y total over x total. So in our calculators, we want to put the inverse tan of 22 divided by 39. That answer comes out to be 29, ironically enough. And then look at your triangle, guys. Did you head north of east, east of north, south of west? What'd you do? You went north of your eastern line. So 29 degrees north of east is your final answer. All right, please apply this to 7, 8, and 9 on your Find and Resultant worksheet.